Okay, we're on. Okay, ready? Okay, chapter 4. Okay, so chapter 4, here we go. Okay, so remember that state affects behavior and behavior affects state.
State affects behavior and behavior.
Right? So state are instance variables and behavior is the methods.
Mm-hmm.
Okay? So if you have strong muscles and you're in a game, then your punches are stronger. So your methods of punching is stronger because your muscles are stronger. Your state. Okay? Okay, so every instance of a particular class has the same methods, right? But the methods behave differently based on the value of the instance variables. So there's humans all have eyes, nose, ears, mouth, whatever it is. But we behave differently because we taste different things and see different things and hear different things and understand different things, right? So the methods we do are usually the same, but they act differently depending on how, all the instance variables. Okay? Okay, so a method you can have parameters, right? So looking at this example, right, we're passing in a number of barks, which is an integer. So number of barks is the parameter. What you pass into it is the argument.
Yes. You says yes.
So you call it number of barks is a parameter, but if you pass in 3, so the 3 will be the argument.
D bar 3 is going to the class of void bar.
Well, it's not a class, it's a method, yeah.
Sorry. Going to the method of void bar, how many bars? Yeah. When you return.
Okay. And so methods can return values. Over here, void means it's not returning anything. If you want to return something, just put integer, whatever it is, and it'll return that. Okay?
Okay.
Okay. So for example, over here, if we are returning 42,
yes,
we have to make sure that it matches this.
Yeah, I mean.
Right? I can't return a dog if I'm saying I'm going to return an integer. This doesn't work. Okay? Remember, by a method you can pass in multiple parameters.
By what?
By a method you can pass in many of them. You can go, for example, over here it could have been number of barks, then a comma, and president, etc. You can pass in 5 parameters. You don't have to do one.
Yeah, you can. Yeah, let's pass it.
Okay, and here's a very important rule. People get very confused about this. When you pass in a argument, it makes a copy of it. It doesn't actually use it. Okay, so this is very important. So remember, if I pass in an integer called x, right? And inside the method it plays around with it and changes it, it's not going to really change x.
Yeah,
it's just changing.
Yeah.
But with remote control, it does use the same object. Remember, remote control, 2 remotes that point to the same TV are both changing the same TV.
Yeah.
So be careful. This is where primitives and object reference variables.
So how are we doing that with the object?
So if you pass in an object, it'll change the remote. It'll make a copy of the remote, but it doesn't make a difference because the remote control is still pointing to the same dog.
So what are you doing about that?
So you have to be careful to make sure that you realize that's what's happening. Because if you think that if you just change, for example, say I have a method that says, you pass in the president, okay, and you might think, okay, it's making a copy of the president, and it's going. If I change it, okay, who cares? I'm not changing the original. No, you are changing the original.
Oh, with the object, yeah, because it's the same, yeah.
It's remote control. Okay. Okay, so remember that you don't have to actually say that you want the value back. Even if a method returns a value, you don't have to pick it up.
Yeah. Sure.
Okay. Okay. Now here is the most important part so far. This is encapsulation is one of the most important, one of the most important things in object-oriented programming. Okay. Do you remember what that is?
It's no, it's encapsulation. It means I know what it is. How can I say that? It's security.
Yeah.
For the state, for the variable. So you insert to right away the change the variable between set and get.
Awesome.
That the user not gonna change the class or who's write the code and then it's gonna mess up everything so it's set and get
Awesome.
in this.
Yeah, so there's one key word is instance variables. It doesn't protect your all your variables, just your instance variables.
Yeah.
Because remember, there's other variables too, like local variables. Those.
Well, this is not no only the
Right.
only the instance.
Yeah. Okay, so so we basically will make all the instance variables private.
Yeah.
And then you put setters and getters if you want to change it.
Yeah.
That's a general rule, but you should basically 99% of the time follow. Very rare do you want to make your instance variable public.
Yeah. And then it's in private. Yeah.
Yeah, you want to make it private so nobody can touch it.
Yeah.
But then you have getters and setters that can change it.
Then usually like under markets like every second I get
There you go. They gotta wipe the Hamas out there, huh? Get rid of them.
Yeah.
You know, there'd be peace out there if I just get rid of those bad dudes, you know?
This is gonna be, but it'll be quiet.
Yeah.
Another couple of years.
Okay, so
Okay, what is how exactly do you hide the what public and private?
okay, so right now the ones you'll 99% of the time use are public and private.
Yeah.
Okay?
Those.
Protected and no modifier you'll almost never use. They're very rarely used.
Okay.
Public means everybody can see it, and private means nobody can see it. Okay? And those are really what you'll basically do. These ones are really, it's very weird. It has to do with package levels, and it's.
We're gonna get to it.
We'll get to it, but even in the real world,
Yeah.
as far as I know, these are almost never used.
Okay.
Okay?
So what do you mean YN not so the
can
package
see it?
subclass and the word cannot see it.
Yeah, so by public,
Yeah, I got
the class can see it. Anywhere in the package can see it. We'll talk about packages soon.
Okay.
If you make a subclass, it can see it, and anybody who wants to look at the class can see it. By private, nobody except for the class itself can see it.
Yeah. Okay, I got it.
Okay, getters and setters are the same thing as accessors and mutators. No one calls it this. Just forget about it. Just call it getters and setters.
Yeah.
These are for losers. Okay, so here we see a quick example. We have brand, number of pickups, and the rock star who uses it for the electric guitar. We just have a get and a set for each of them.
Yeah.
Now remember, if we don't need somebody to access it, we don't have to make a getter or setter.
Yeah.
Right?
Yeah.
If it's known in the outside world is seeing it, you don't really have to do that. Though it's might be good use to do it anyways.
Yeah.
Okay. So general rule of thumb, make all your instance variables private.
Yeah.
And then make getters and setters and mark them public. And make sure that you put good security on those getters and setters that they only change the variables to good values.
Yeah.
Okay? One good thing about getters and setters, even if you have say you have something that's okay, who cares? You know, like what's so bad that can go wrong? The good thing about making getters and setters is that if in the future you want to change it, it's very easy to change. Because they're already using the get and set method. And therefore in the method you can always change around the logic. But if there's no get set method and they're accessing the variable directly and you have to make a get and set, you're breaking their code. Because now you have to make that private and new method, and whoever's using your class.
So getting to always good.
Always good. Yeah, it's always good. Okay, so remember, this is a unique thing for instance variables. Right? Instance variables, they always have a value, even if you don't assign one. Integers will be 0. Floating points, like decimal, etc., will be 0.0. Booleans will be false, and object reference variables will be null.
Yeah.
But remember, this is only by instance variables. By local variables, they have none.
You have to assign.
You have to assign it. And you can get errors if you don't. Okay, so remember, instance variables are declared inside a class, but not within the method.
Inside class, but not with it.
Okay, so in other words, it's part of the class. That's the main thing. The book doesn't say it well. Instance variables are what define the class. Yeah. Okay? So locals are not going to default values. You got to be careful. For example, over here, you see how this is a method called go.
It's one go.
So x, and then we do z plus x. That's going to crash. The compiler will say not happening because we never just said what x is.
Mm-hmm. Yeah.
Okay. Okay. So here we go to the final part, and this actually is very important because this gets also very confusing for beginners. Over here, what does equal do?
Equal, it's equal, like whatever equal the object or the whatever, like 1 = 1.
Right.
You know what I mean?
Now the by primitives this is easy, right?
Yeah.
Because 1 = 1.
Yeah.
But by an object, what does it mean to one object?
Change the. Hold on a second. By object, I think it's. Hold on a second. There you go. Hold on a second. Also.
So by object, it just checks. By the end of the day,
Just
equal.
check it, but it doesn't change it. Like
Well-
even they have the same object, like with the same. If they didn't assign them together, like A is equal to B,
Right.
you know what I mean? They're not gonna be the same. You know?
Right. So in other words, it just checks the memory,
Yeah.
what's in the variable. So if in the variable are 2 points to the same memory,
Yeah.
the same object,
Yeah.
then they'll be the same. So that's, it's equal really is only good
What's wrong?
for primitives. For objects, it can be good if you want to find the same exact object, but usually you want to use dot equals.
Yes, the dot equal we need to. Yes,
Okay, and we'll see later on in the book
a lot.
how dot equals works. Okay, for a string, it's very easy, right? You just do, make if
X dot equal is
Right.
Z.
right. That's
Then
fine because strings are simple. But how do you know if a person, if you're Regev and I make another object that looks exactly like you?
Yeah.
How do I tell the system that they're equal, even though they're not?
Yeah.
And that we'll see later on in the book. How, in other words, we're going to take equals, which is a method, and we're going to actually
Yes.
override it and make our own way of saying this is how we define that regulars are equal. Okay?
Okay.
Cool. End of chapter 4.
You remember something?
So far, so good?
Yeah. No complaint. I didn't go down, remember that.
Chapter 5.
Okay, just this how we start the.
Okay, so chapter 5 gets into the real meat of making programs. Okay? And here is the stuff that's annoying as hell, but is so important.
I know.
Always make a flowchart. Always. If you skip it out, you'll be trying to work with a program in your head that you think you understand, and you really don't have it rocked down solid. Make a flowchart. Remember, a flowchart
Yeah.
is nothing to do with Java at all. It's just how you can explain it to somebody else,
Yeah.
and therefore explain it to yourself as well. You got the flowcharts down?
I got the flowchart, yes.
Okay.
The flowchart, the only thing that we need to have is practice.
Yeah.
Practice to the flowchart that is scared. You know how to write the flowchart.
Yeah.
You know, basically, it's you understand
Yeah.
what
All we
they
have is
want.
3 things: a circle for start and end, a rectangle for doing something,
Yeah.
and a diamond for decision.
So you have to practice to understand how to do it and make it easy. Yeah. Okay.
Okay, yeah, so maybe we'll have to, maybe before we go into chapter 7 again, we'll do some homework on the past couple of chapters.
Okay.
What do you think?
On the flowchart and okay.
Okay.
Let me see this one. Okay. Perfect.
Yeah. Okay, so here's another important idea is that when you're thinking about Java programming, you want to think about how it works in real life, because then you'll be thinking of objects
Yeah.
and classes. Don't think of just, okay, step 1, 2, 3, 4, 5, 6 to get the job done. Because then you're thinking like SQL. Just
Yeah.
go through things you're going to have it done. You want
It's
to
like an object. Think
Right.
about how it works.
Right, so you have, whatever it is, example of, say, a game of a boat on the water rocking back and forth.
Yeah.
Don't just think of like, okay, I want to make an image of a boat and the water and it knocks the boat up and down, right? I want to have a boat object.
Yeah.
And the boat object has these methods and variables. Then there's water, which has
Yeah,
that.
the water going back and forth.
Right.
And then okay.
And that will knock anything that's on top of it. Boats. Okay, so you want to think exactly how it works in your life.
Yeah.
Okay.
Anything that tries to react to that. Okay.
Okay, so developing a class. So now once we're done with the flowchart, you want to get down to the class level, or later on we'll talk about interface level. It's the same thing. Now here you have basically 4 steps, but 6 if you want to make it a little more clear. And here how it works. Number 1 is make the UML. These are the UMLs, right?
Yeah. It's not, no. Before it's not. This is when you start develop the class.
Yeah. So make this and the pseudocode. I would do these hand in hand, same time. The UML and the pseudocode, you work together because while you do the UML, you can be doing pseudocode. Pseudocode, however, is not code. It's not Java. It's just.
I know. You mean the way that you make it to understand how to build.
Right. How are you going to do it later on?
This one I need to.
Okay. These steps.
By heart.
So these 2 steps are hard, but they're not that hard. Test code is annoying, but you have to do it.
Yes. Also test code.
So test code is where you make your class exist already, and you start writing as if that class exists, as if you're using it. So say you have a person that punches and kicks and runs. I'll make a class test person, and I'll do regev is equal to person, regev dot kick, regev dot punch, regev dot run, and and then output print line, is this working right, and then that's your test class. Then you actually go write your class.
Yeah.
Here's what a person is. He has eyes, he has ears, he can run.
Yes, I know, I got you. So yeah, also,
Okay.
we have to, I guess we're gonna need to put attention for that.
Yeah.
I think if we're gonna put attention on those 3, we can have much more easier in the rest one.
Yeah, for sure, 100%.
So this is more important,
Yeah. And then you go to real code. After that, you do testing and debugging. But that's afterwards. The main things are the flowchart and these 4 steps.
Yes.
Okay, so we'll skip this. This is just a pseudocode example. I don't actually like their pseudocode example. Pseudocode has to be what you like to do. So don't look at anyone else's pseudocode.
Okay.
However you want to make sense in your brain, do it.
Oh, I know it makes sense, but I want to make sure that I'm writing good, that I can.
Yeah.
I know how to change it to code.
Yeah.
It's supposed to be easy to change it to code.
Now, the test code. There's 2 reasons why I want to do it right away. Number 1, if you don't do it right away, you'll never do it.
Yes.
Because once you have a working class, you're busy enough on other things, you're not going to get back to it. And number 2, it actually helps you build. Because what does a test class mean? A test class means I'm actually looking at it from a user perspective. User, not necessarily a human being, but other code that will use this class. Yes. And you start seeing how really it'll work. Okay? Here's just some random stuff that came up in this chapter. Say you want to take a string and convert it to an integer.
Yeah, integer for it.
Right? Integer parse int and just put it in there. Okay, remember, this will crash if it's not 3.
Yeah. Pass on integer.
Yeah.
And only numbers, like, yes, I got it. String number.
Okay. This one, remember this one?
Yes.
So this is how you...
Run into each of the location cell, each of buckets, and do the what is done.
Okay, so this will go through any array.
Yeah.
Okay, this is just called the increment. It'll increment it by 1. Okay, and then break gets out of a loop early. Okay, so now we're almost done with the shadow. This is a very important part. So we did for loops, we did while loops, and then we did this for each loop, right? Going through each bucket. Okay. Okay, so here's the basic rule. Choose for loops over while loops when you know how many times you need to repeat the code. That's the rule. For loops are much easier and much more succinct. They're very straightforward.
So for loop is X, and I'm going to do this one. x equals 2x higher. You see that? It's there.
Yeah,
Okay.
so here's what
I
it
didn't see it. Okay.
Right, we go over here, we initialize it, we have a Boolean
Okay.
test if it wants to continue, and then increment.
If you know how much.
Yeah, so these are much more straightforward, but you can't use these if you don't know how many times to loop.
Yep. Yep.
Okay? Okay, so if you have a number you want to convert to an integer, you can also just do it like this. You put a parentheses and put it in there, and it'll convert it.
Number and convert it.
Because this returns, remember, something between 0 and 1, or whatever it is, and knock it to this, but it's going to be decimal points. You can put this right beforehand and it converts it to an integer.
So do not do the decimal part.
Yeah,
Okay.
just removes it.
Okay.
Okay. Okay, we're basically done. Let's just do this last thing. So here's a comparison between a while loop and a for loop. As you see over here, they're doing the same thing. This one's much more straightforward.
This is yes. It's not
Okay, but a while loop is needed if you don't know when to get out, and they're used quite often. For example, in network programming, you have to listen to a port to see if data is coming into the port. You got to just go loop through the port every single second, every 2 minutes, or every minute. Or on your Androids and your Android app, say you have Gmail, and Gmail updates every minute. It checks to the cloud.
So it's a loop.
It's a loop. Every minute it checks.
Because you don't know. Yeah.
It's never going to end. There is no end. The loop just goes on forever.
Yeah.
Okay?
Yeah.
Yeah. Okay, here is casting.
That is, I'm going to be guys. Not convert?
Yeah.
Yeah.
That's it. So you just put this symbol beforehand and then cast it. Remember, casting will work even if it doesn't make sense. You got to be very careful.
Yeah.
Okay, here's XP, and this actually will make sense for us. Programmers
Need to follow by those on.
Yeah,
To be a good
and-
programmer.
and this we'll do later on, mixed all uses. But here is one of the ports that many people make a big mistake on. No killer schedules, work regular hours. Now, this is why
Morning is a killer schedule.
it is and it isn't. And the way I think it's nuts. The problem with programmers is they always think nighttime is better. They stay up late, and I'll tell you, working in the workforce, the programmers I know who made it to the top are ones who wake up early.
Yeah. Look, I also think like night is maybe comfortable to work because it's quiet. But I think like for me, I think I can work anytime, like when I know
You might have to change
I have
it.
a cool white area.
Yeah.
Like I know I can focus, so I don't have a program at home.
Okay. Okay, so these we won't go through right now, but let's make okay. You want to make small, frequent releases.
Yes.
This means if you're making a class that's a complicated one, don't go all at one shot. Do small piece, test it. Small piece, test it. Okay, and that's
that we made it like
yeah, and do one at a time. Don't do a whole everything in one shot. Okay, never go to iteration loops. That means do small loops of changes. One change, then go back another day, another change, another change. Don't go for one whole shot.
Yeah, it's just
It's the same thing as the first one, really. Okay, over here, don't put anything that's not in the spec.
Yes. Be smart.
Yeah, so if you have a program you want to make, say for the school that we'll hopefully be doing, right? Yeah. If we have requirements in the school that they need in the app, let's do those first. Don't add, okay, this would be a cool feature. They can do GPS and find where they're. First, put the core stuff in there. Always write test code first. It's a pain in the rear, but you gotta do it. Later on, we'll learn about.
You can give them like the idea, like what you think, or you can tell them like the more cool stuff. But it's good to let them know.
Well,
Or not even thinking. Like even think about something good to have to the app. And it's not
Right.
a spec. You like it's anything is gonna. You let them know. You just don't.
It really depends. If you're building your own app,
Yeah.
then you just have to make the rules by yourself. The point is that once you have things set, don't add things.
Yeah.
First, get that done.
Yeah, and then okay.
But it's if you're working with somebody else, you have to put a school app. The most important thing is to have what they call a knowledge expert. I'm not a knowledge expert in schools. I don't work in a school, but I want to build an app for them. So I really want to get someone from the school to build the app. They're not going to actually physically make it, but they're going to be telling us exactly what is needed, what is wanted, and we just do it for them. And you work in a school, so you probably have a lot of ideas yourself that you can work with. Okay, no killer schedules. This is so important. I've tried so many times to work at nighttime. It does not work. It does not work because then it throws off the next day. Because next day is when you actually have to communicate with people, and then you just throws that one. You fall schedule. Doesn't work. Okay. Refactor. That means if you see something in your code that needs improvement, improve it. Just go ahead and improve it.
Yeah, but just don't change the spec. Just improve it.
Right. If you just see something that can be done better, you have a design and you see, well, this shouldn't be casting. It should be first checking to be casted.
Yeah.
Good. Okay. Don't release until it passes all the tests. So we have unit tests to make sure they're all passed. Do realistic schedules. Okay. Remember, do small releases. Keep it simple, and program in peers. So this is very good because it makes everybody in the team know what's going on, and everybody can criticize each other and help each other and give ideas.
Program in peers.
Yeah.
What do you mean?
With other people.
How?
So, for example, we're making a program. We should both be working on separate pieces, but then switch and then go back and forth and say, "Hey, Greg, you're doing that wrong," or "That's an awesome idea."
Oh, so everyone. Okay. That's not gonna work on one thing.
Yeah.
Okay.
Therefore, I can get your ideas, you get my ideas, you get my criticism, I get your criticism. Okay, that's 5.
That'd be really important to do.
Last chapter, then you're up to you're up to chapter 7.
Oh, yeah.
Okay, Java library is the Java API. That's what it is. API is the programming interface, and that is.
No, API is the library.
Yeah, that's the same thing.
Oh, library. Java library.
Yeah,
Okay.
application programming interface. I think it stands for. And that's how you do. Java provides thousands of classes. There are so many, it's ridiculous.
Yeah.
Okay. Okay, so let's go to an array list. The array list is something that Java provides us.
Mm-hmm.
Okay, so tell me about array list. Tell me about these methods.
Okay, basically array list is create you an array, a list actually of a type of object that you want, and add object. Basically, you add the object to the array. You declare no, you add the object to the array. Like you put the object in the array, remove is removing from the array, contain is to make sure if this object is in there, like say you want x, to make sure x is in the array, is empty. You check if this bucket in the array is empty. Yeah.
I think it empties for the whole entire thing.
If the list has no.
It empties the whole entire thing.
All the list. Oh,
Yeah.
But you can tell them that, but you can check if one bucket. Oh, does it contain?
Yeah, it contains what we did.
Index of index of is give you what the name of the object. No, it give you the number of the place in the element and
Cool.
array list. Size will tell you how many buckets you have, how many objects. You get the name of the index of the object. Yeah.
You'll get the object itself.
Yeah. Get the object. Yeah. Get it. Bring the object back.
Cool. Okay, so if you got that down, if you get that really down, that helps you so much.
Yeah.
You use it quite often. Remember,
Okay.
when we learned how to connect the database, you were pulling SQL queries, the data right into array lists. Okay.
And array list contains.
Right. Okay, let's go through that. Okay, so
What is that?
this is for the game. We're not doing the game anyway.
Oh,
So.
okay.
Okay, so remember, this is and this is or.
Yes.
Okay, so there's a thing called precedence, and it says which comes first. Just don't use it. Don't think about it. Just use parentheses. Okay, always use parentheses.
Yes.
If you have a complicated if statement, use parentheses.
Okay.
And it'll happen. You'll see sometimes you'll have a crazy if statement.
Yeah,
This
I
and that, or this, or that, and that. Use
The
parentheses.
game that you came up with, like, it was like something. But I think it was good that what he gave us, like to make us to think
Right.
deep.
It's a really.
But I
nice
don't think it wasn't on. I think it wasn't on our level yet. The
Perhaps.
movie. But it was interesting that you get progress that now I understand. That,
Yeah.
I think sometimes you do it.
Yeah, we'll have to go over that game again,
Really?
or at least something of it.
No, I don't care.
Okay, so what's this one doing over here?
What is this one? If no, not good. What is the name of this thing? Never mind. If it's not
Okay, cool.
this, what is the name?
The exclamation point.
Exclamation point is like if it's not equal x, if x is not equal, so do
Okay.
the non.
And why didn't we use equal equal?
What?
Why
Because if it's a string,
Cool. Yeah. Perfect.
because you can string it's an object,
Right.
so you can.
So even if this was x, it would never be equal anyways.
What?
If brand is x, right, and you did not equal, it'll never equal it because strings are two different objects. So this you have to do this. Okay.
If it's the same in the heaps.
Now, this part's a little confusing. I hope you guys got this part. These are called circuit operators. Because if one, for example, let's do this example over here. If ref var does not equal null, right? And ref var is a valid type, then do this, right?
Yeah.
Now, why can't we just put this in here? And don't do that?
Yeah, if refer not equal null, and it was it's valid type, because it's first of all, I think I understand it, but I want to make like if first of all it tells that if the first one is
let's put it in this new screen so you can focus on this. Let's go here. So we're gonna be here. Okay, so here we have something that looks like this.
yeah.
What is wrong?
If the first one is true, don't do the second one.
Okay, so I hear you saying. Let's go like this for a second. What would be wrong with doing this?
Because if it's null,
Here we go, and it will fail.
it's gonna fail. So you want to make sure that it's first of all it's not null,
Right.
And then check what's going on inside.
Okay, so what if it is null? This will fail again.
Yeah, but it's not gonna go to him.
Perfect. Okay, so you got your couple 100%. Okay.
It's not. It's gonna start by the null, and then it's gonna go back.
Right.
Whatever.
So if by an and statement, if this is not true, boom, it'll jump out already. That's called a circuit operator. It jumps out. And by or, right, the same thing but in reverse.
But or.
If any of them equals true, it jumps out. It doesn't need to check that
And
one.
if it's or.
Well, this is a stupid example, but say if I have, if ref var, say I have this. If, x equals 1,
Okay.
Or x equals 2.
Okay.
Once x equals 1, it doesn't have to check this.
Yeah, because it's already equal.
Because when it equals, it's an or, so it jumps out.
Oh, okay.
It just saves the machine
So
time.
if it's not equal, it's jump, but it's the same with the hand.
Right, in other words, it jumps once it needs enough information, it jumps.
Yeah. So if x equals 1 and x equals 2, so exactly it's doing the same. If x equals 1, it doesn't go to the second one?
No, because then it does, because it is true. Here's the big difference.
Only if it's not.
Right.
It's not. Oh, okay.
So by and, if it's not true, it jumps.
Yes.
And by or, if it is true, it jumps.
By or, if it's true, it jumps.
Right. By and, if it's not true, it jumps.
Yeah. By and, if it's not true, it jumps. And if it by or, if it's true, by or, if it's not true,
It has
it's
to
going to second.
Yeah.
Until it's gonna find. Okay.
Yeah. It's just for and, it's very important because you'll have those nulls. You need it. For or, it's really just to save time. And it can be important. Say you have something over here to take. Say you have like a lot of or statements. Or this.
By or, if it's not true, it jumps. No, by and, if it's not true, I need
Right.
Yeah.
Yeah, you'll get it down very quickly. You'll see. It's not
Yeah.
and it's not really important for or that much, except for speed.
Yes.
It's more important for the and because you'll need it to check things if there's no of that. Okay.
repeat.
Okay, these are, if you just use one of them, that doesn't act as a separator. Just don't use these. They're so rarely used. Don't use it.
Okay.
Okay, using the Java API. This just goes on forever. Use that, you'll always learn more things about the API when you need different things. But you can't master the whole entire thing. You don't need to. You have to know what you need to do. But you have to know which package something is in to use it. Right? So, for example, if we're going to, let's go to, say, chapter 6, let's find our leader class, right? So over here, we have to import these because we're using them.
Yes.
Okay?
Mm-hmm.
So, if we wanted to, we could have just went, we could have just went like this. And that would import everything from the util. And then I can just go like that and use it. But
A lot of people doing that?
yeah, if you're doing a lot of stuff that's in this package, then do this. If we're just one or two, it's better just to do it like this.
But I think for now, it's better to do like that because I want to know what
Exactly.
what else in util. So
Yeah, so this is good if you're using small. If you're using 10 of these things in util, just use a star. Okay, now, for example, a string is in the package too, but since it's in the java.lang, we'd never have to import it.
Java that what? Ah, you don't.
Because that Java is for it, right? Like string is part of the library, but we have it automatically. Okay. Later on in the book, we'll learn actually how to make our own packages. Okay, packages are very good because they organize your code. So you have one package that has to do with your application, and then another package has to do with handling database stuff, right?
Yeah.
Okay. We'll learn later on why packages are more important than they seem. Okay. Okay, now remember, here's an interesting thing. So when I import this, the cool thing about Java is it's a compiled language. So this is actually compiled already.
Mm-hmm.
So it doesn't make my code any slower by putting this in there. By Python, you gotta be careful
It can be compiled.
because there's no compiler in Python.
Oh, there's no.
So if I do this in Python and I import a library, it's got to actually import a library and run it to make it work. By Java, it's compiled already, so this will not make your code any slower. And it's a big thing because in Python, you want to be careful of what you're importing. You don't need it, don't do it because you're slowing down your application. Over here, that's not the case. By Java, it's compiled already. Everything's done. We'll make your code 1 dot slower. Okay, so how do you play with the API? We probably won't play with it for a while, really, in the sense that you're actually just playing with it. We're gonna focus on what we have to do and then look at the API to find things to do. But when you have time, get a book called this, or right now it's probably more recent edition, and this just shows you what they're out there. It'll show you a quick page of there's this class and it does basically this. Then you can look up over here on the internet and find out more details.
Okay.
Yeah, but in the beginning, for your first realistically, your first couple of years, you were just getting books on things you want to do. You want to make an Android app, you'll be getting a book on how to build an Android app, and from there, the book will tell you what parts of the API you need anyways. Oh, that's it, man. You're done.
So we're gonna go back to what we say. We're gonna keep chapter 7.
Yeah, so we're up to chapter 7 for tomorrow. So I guess today.
Oh, what about the
No, okay, yeah, we stop this thing.